Good evening, everyone. Let us discuss. I am going to solve question number 10.6. So before that, we need to read this question. A steel tape of 1 meter long is correctly calibrated at a temperature 27 degrees Celsius. So there is a steel tape which is 1 meter long and temperature at a 27 degree Celsius. It is correctly calibrated. Okay. The length of the steel rod measured by this tape is found to be 63 centimeter. 63 centimeter on a hot day when the temperature is 45 degree. So what happens when temperature rises, then what will happen? When temperature rises from 27 to 45 degrees Celsius, so what will happen? This 1 meter long tape will become more larger, and at this time if you want to find the length of the rod, so let us suppose there is a rod, okay, there is a rod, and if I will measure with this measuring tape at a 45 degrees Celsius, so it is the extended form. Earlier its length was this only, but after the 27 rise in a temperature, that is delta T is equal to 80 degrees Celsius. So after rise in a temperature of 18 degrees Celsius, there is a increase in the length. So whatever earlier it was showing 1 meter, so it will be definitely 1 point something else meter, but it will show it shorter. It means that the true value will be less than the measured value. Okay, so we should use this concept that measured value is equal to true value into 1 plus alpha of the object minus alpha of the scale into delta T. So this is the main thing. We can also use this way, that measured value is equal to true value 1 plus alpha s into delta T. By binomial expansion we can do this. So this is not a plus, this is a minus 1, this is minus 1. So from here we want true value of the rod. So when we want true value of the rod, so we will exchange it. So we will get measured value 1 plus alpha s into delta T. So if we put the value, measured value is 63.0 and 1 plus alpha s is approximately 1 point. It is given 1.2 into 10 to the power minus 5 per Kelvin into temperature difference. So the difference in the temperature is delta T is 18 degrees. 18. So when we calculate this, so we will get a value that is supposed to be 63.01 centimeter. So this is the true value, and but in measurement it is showing the less value. Now the second part they are asking that what is the length of the same steel rod on the day when the temperature is 27 degrees Celsius. Since when temperature will be 27 degrees Celsius, so what will happen? Measuring tape will show the true value. Measuring tape will show the true value, but at the same time rod will also decrease the size, So when it will decrease the size, so what will happen? When it will decrease the size, since scale is also decreasing and the rod is also decreasing, it means that there will be no change in measured value. So the measured value or true value, measured value will remain same. Measured value will remain same because both will contact at the same dimension, because both are made up of same steel. Remains same. So from here measured value will be equal to 63.0 centimeter. So measured value, this is equal to true value. So whatever you call, so both will be the same. So I hope you have understood this question. Now there is another question. It is a large steel. Read the question at first. A large steel wheel is to be fitted onto the shaft of the same material at a 27 degrees Celsius. The outer diameter of the shaft is 8.70 and the diameter of the central hole in which the wheel is to be fitted is 8.69. Now the shaft is cooled using dry ice. At what temperature of the shaft does the wheel slip on the shaft? Assume that coefficient of linear expansion of the steel is this. So let us draw the diagram. Let us consider this is a shaft and there is also another hole. This is the wheel. So this is a wheel. Okay. Now the diameter of the shaft they have given, diameter is 8.70 centimeter, but the inner diameter of the wheel is given as 8.69 centimeter. So it is not possible to fit. Not possible to fit, right? So what we need to do, either we have to increase the temperature of this material so that it will expand, or decrease the temperature of the shaft. So our option for as per the question, we need to decrease the temperature of the shaft only. So how much change in a diameter should be done? Since we can also use the formula for the areal expansion, but here we will use the alpha only, linear expansion only, because they have given diameter as well as alpha. So change in a diameter, that is delta d, is how much? If we can do this, change in a diameter required is how much? 8.70 minus 8.69. So this will be 0.01 centimeter. Now change in diameter is equal to original diameter into alpha into delta t. Now original diameter was how much? 8.70. So we can put here 8.70. Change in diameter is 0.01. This will be into alpha. So the value of alpha is 1.20 into 10 to the power minus 5 into change in a temperature. So change in a temperature is this. So from here change in a temperature will be 0.01 divided by 8.70 into 1.20 into 10 to the power minus 5. So when we calculate this, so our answer will come to 95.78 or 95 point, or we can also write here 90. We can also write it is as a 95.8. So this is a change in temperature, okay, degree Celsius or Kelvin we can say. So change in temperature is equal to, see here, change in temperature is equal to final temperature minus initial temperature. So we want final temperature up to which we can cool so that it will easily slip in the wheel. So this final temperature will be change in temperature plus initial temperature. Sorry, since change in temperature is negative, so here we need to put here change in temperature as negative. Why? Because it is decreasing. So initial temperature was how much? Initial temperature was 27 degrees Celsius minus change in temperature is how much? This is T initial minus change in temperature. So change in temperature is how much? We have got 95.8 degree Celsius. So when we calculate it, so we are going to get the temperature as 69 degrees Celsius. It is not 69 degrees Celsius. I have taken it as approximately, but if you want accurate, so you can find accurate. So accurate will be 68.8 degrees Celsius. So approximately the final temperature will be minus 68.8 degrees Celsius or minus 69 degrees Celsius. So whatever you want to take. So I hope you have understood this is the final temperature. Okay. Now let us do this question. A hole is drilled in a copper sheet. So let us consider there is a copper sheet. There is a copper sheet and hole is being drilled like this with the driller. The diameter of the hole is how much? The diameter of the hole is 4.24 centimeter, right? At a temperature of 27 degrees Celsius. Now what is the change in a diameter of the hole when the sheet is heated to 227 degrees Celsius? So the final temperature is how much? 227 degrees Celsius. So what will be the change in a diameter? So df is we don't know df, and we want change in a diameter. So change in a diameter, basically change in a diameter, change in a length, since we will talk about the linear expansion only. So change in diameter is equal to initial diameter into alpha into delta t. So no need to do final temperature, final diameter at all. So change in diameter is equal to initial diameter. So initial diameter is 4.24 centimeter into 1.7 into 10 to the power minus 5 Kelvin into change in temperature. So initial temperature was 27, final temperature was 227. So change in temperature is equal to 227 minus 20. So this will be 200 degrees Celsius or degree Kelvin. So this will be 200 Kelvin. So when we multiply it, so our answer we will get as 1.44 into 10 to the power minus 2 centimeter. So this much amount of diameter change will happen while drilling the hole, and when we expand it to the temperature of 227 degrees Celsius. So I hope you have understood this. Now let us do the question number 10.9. A brass wire of 1.8 meter long at a 27 degrees Celsius is held taut with the little tension. Okay. See here again, you need to read the question first. A brass wire of 1.8 meter long at a 27 degrees Celsius held taut with the little tension between the two rigid support. If the wire is cooled to a temperature of minus 39 degrees Celsius, what is the tension developed in the wire? If the diameter of the wire is 2 mm, coefficient of linear expansion of the wire is 2 into 10 power minus 5, and Young modulus is given as a 0.91 into 10 power 11 Pascal. So let us draw the situation. So situation is that there is a wire and it has been taut here. So the temperature is here 27 degrees Celsius. Now temperature is 27 degrees Celsius. Now when the temperature will drop from 27 degrees Celsius to minus 39 degrees Celsius, so what will happen? This wire will try to shrink. So when this wire will try to shrink, so what will happen? If suppose there is a no rigid support, so what will happen? Its length will reduce somehow. So earlier this was the situation, so there will be the gap, but here it has been taut. It means that there will be a tension, there will be a creation of a tension. Okay, there will be a tension in the there will be a tension in the tension in the wire. So if there is a tension in the wire, so we need to find what is the tension. So we know that the formula is stress developed is equal to Young modulus of elasticity into alpha into delta T. Now from here, stress is equal to force by area, that is equal to Young modulus of elasticity into alpha into delta T. So from here, force, that is equal to tension, this is equal to Y into A into alpha into delta T. Now put each and every values. So what is the values? Let us suppose the values given in Y is equal to Young modulus of elasticity is equal to 0.91 into 10 to the power 11 Pascal, and area is given as pi into r square. So pi into r square means what? Diameter is given 2 mmc, so we can convert into 1 into 10 to the power minus 3 as a centimeter meter whole square. Okay, so this will be the area. So alpha, the value of alpha is how much? Alpha, that is coefficient of linear expansion, is 2 into 0 into 10 to the power minus 5 10 to the power minus 5 Kelvin inverse. Okay, so delta T, will be equal to how much? Minus 39. Final temperature, change in a temperature is minus 39 minus 27 degrees Celsius. So change in temperature is approximately equal to minus 66 degrees Celsius. So this is a change in a temperature. Now finally we need to find a force. So force will be how much? So force, we need to put the value, force or a tension will be equal to Y, that is Y is equal to 0.91 into 10 to the power 11 into area is equal to pi into 1 into 10 to the power minus 3 whole square into alpha is 2.0 into 10 to the power minus 5 into delta T, that is 66 degrees Celsius. So finally with the tension, when we calculate it, so the finally tension we will have 0.336 centimeter, or we can finally tell as T is equal to 0.3 centimeter approximately. So this is the final answer for this question. I hope you have understood this. Okay, now let us discuss next question, that is 10.10. so the question they are asking that a brass rod is there, of a length 50 centimeter and diameter 3 mm is joined to a steel rod of the same length and diameter. So let us draw brass rod as well as steel rod. So this is a brass rod and there is another rod which is made up of steel. So this is a steel rod and the dimension is same for both. So here its length is how much? Length is 50 centimeter. Area, diameter is same, that is 3 mm. Okay, what is the change in the length of the combined rod at a 250 degrees Celsius if the original length is 40 degree? So earlier the temperature was 40 degrees Celsius, but the final temperature has been 250 degrees Celsius. So the change in a temperature here is 250 minus 40, so this will be 210 degrees Celsius, or change in temperature we can also take as a 210 Kelvin. Now we need to find total change in a length. So let us consider change in a length delta L. This is for brass and this is for steel. So this is delta L for brass and this is delta L for steel. We need total change in a length. So the total change in a length, that is delta L, is equal to change in a length of the brass plus change in a length for steel. We know the common very important formula, that is change in length is equal to L naught into alpha into delta T. So we can put here the values. So for a brass, case of a brass, L naught alpha brass into delta T, because change in temperature is the same and length is also same. For steel also length is same, but alpha steel is different, but change in temperature is same. So when we can also take here common L naught into delta T as a common. So we have a alpha brass plus alpha steel. So can we put the value? So original length was 50 centimeter. So we will take each and everything in a centimeter only, so that our change in a length we will get as a 15 centimeter. So I have taken 50 centimeter into change in length is 210. From here we have already got 210. So alpha brass is 2.0 into 10 to the power minus 5, and steel has also the same power. So can we put here 1.2 and 10 to the power minus 5 as a common? So if we will do this, so what we will get? 50 into 210 plus 2 and 3.2 into 3.12 into 10 to the power minus 5. Now finally total length delta L will be how much? So when we calculate this, delta L, so the delta L will be approximately is equal to 0.336, or it is equal to 0.3 centimeter. One thing I have missed here, it is not in a centimeter, sorry for that. It is tension here. Let us correct it. So that here tension. So tension will be how much? So tension will be approximately is equal to 377 Newton, or tension will be 380 Newton. We can assume at 380 Newton approx, if we round up. So this is the thing. So correct it. I hope you have understood. And this is 0.3 centimeter. Okay. So this is change in a length, which is 0.3 centimeter approximately. So I hope you have understood each and everything. Thank you for watching my videos.